All right, so good morning, good afternoon, good evening to everyone, wherever you're joining us from. Let's start with the meeting. So my name is Johanna Siliakus. I work with the Transport Sector Group at ADB, and I'll be chairing today's meeting. So I'd like to first warmly welcome you to this e-mobility community meeting on the sustainable end-of-life management of electric vehicle batteries. This discussion is arranged under the umbrella of the e-mobility support and investment platform for Asia and the Pacific. This is a platform that aims to build capacity and support the scaling up of financing of e-mobility initiatives. The platform is managed by ADB. It's co-financed by GEF, the Global Environment Facility, and it's co-implemented by UNEP. And today's session is a panel discussion in a series of 2 sessions arranged to cover different aspects of the EV battery life cycle. So we already had a first one on battery manufacturing and mineral sourcing, which was arranged on the 19th of February. We will share a link to that recording in the chat later on. Just to briefly run through the agenda, so we have an action-packed 1.5 hours ahead of us. So we'll kick off with welcoming remarks by Jamie Leder, ADB's Transport Sector Group Director. After this, we'll have James Baker, Senior Circular Economy Specialist at ADB, who will continue with introductory remarks to help set the scene. We'll then present our distinguished panelists, who will start with short presentations before moving into the panel discussion. And the panel will be moderated by Jamie Leder as well. We also aim to make this session interactive and engage with participants throughout the session today. So we hope to hear from you as participants as well. But yes, so without further ado, let me hand over to Jamie. So Jamie Leder is the Director of Transport Sector Group, and he will provide us with welcoming remarks today. So over to you, Jamie. Thanks.
Thank you very much, Johanna. Welcome, everybody. This is quite an interesting and also an important topic, looking at the same sustainability angle, particularly at the end of life. As Johanna said, we did something about the manufacturing, the front part of the battery production. But just to put it in context, I think we're all aware that the transport sector now accounts for about 1/4 or 25% of energy-related global emissions. Perhaps more daunting in this part of the world is that it's the sector with one of the fastest or high rates of increase, and much of that is in the transportation, land-based transport sector across Asia and the Pacific. We're very much in favor of the avoiding, shifting, and improving to decarbonize the transport sector, avoiding the need for travel, shifting to more energy efficient and therefore less polluting modes of transport, and particularly on the improving the transport mode. And that's where the e-vehicles come in, and this sustainability session relates to that. The vast majority of the improvements under avoid, shift, improve are likely to come from the improve. So again, that just demonstrates how important this area is. ADB has been very active. We have so far financed about 75,000 e-vehicles. And in this part of the world, a lot of that is in the 2-3-wheelers and the urban public transport. That is also important for this discussion because those 2-3-wheelers will be manufactured on a smaller scale than perhaps the large automobile global players. So again, how we work with governments to ensure suitable policies, suitable regulation, suitable enforcement for the end of life is very important, particularly for those 2-3-wheelers and maybe the public transport as well. Final points I wanted to raise is at the end of life, it's not just how we dispose of that, but is there a second life for these batteries? Yes, the power may have deteriorated, but what are the other options? So it's not all sort of downside in terms of how do we ensure the sustainability, the environmental issues of end of life, but looking at some of the opportunities that we can use those batteries in other forms as well. And we have some excellent panelists who know far more about this than me. So let me pass it back to them, and we can see where these sustainability issues on end of life or different types of life in the second life and those opportunities. Thank you very much.
Thank you so much, Jamie, for talking us through the very key topics that we will be discussing as well further along today. So let me now, without further ado, hand over to James Baker for introductory remarks, also for setting the scene. James is Senior Circular Economy Specialist at the Climate Change and Sustainable Development Department at ADB. So over to you, James. Thank you.
Great. Thank you, Johanna, and thank you, Jamie, for those introductory remarks. And welcome everybody to today's meeting, where we're going to explore the challenges and the opportunities around sustainability for electric vehicles. And we talk about sustainability, we talk about circular economy, and one of the challenges of circular economy is the number of definitions, 157 at one count. But the way that ADB is thinking of circular economy is at micro and macroeconomic scale. So we're thinking about materials, components, products at the microeconomic scale, but then at the macroeconomic scale, we're looking at these much larger systems approaches. And that's, leads into the definition that we've sort of adopted currently, which is of circular economy, which is a programmatic systems approach to support economic development that decouples economic activity from the consumption of finite resources, eliminates waste pollution, circulates products, and then maintains the value within the economy, supports the regeneration of natural systems, and incorporates renewable energy. And I do not apologize for reading that because it does not roll off the tongue. But what it does do is it shows us that we need to think about these processes, these activities, these investments in a much larger scale than we have done before. And as Jamie mentioned, as the transport sector grows, there are these huge opportunities for us to invest to support the overall decarbonization of transportation, but we need to think more deeply, more widely than we ever have done before as we start to develop projects. And in actual fact, the ADB private sector team is looking at a project in Georgia where we're not only investing in the vehicles, but in the entire ecosystem. We're looking at the charging systems, the charging stations, the repair network, the repair specialists, but also the end-of-life management, the end-of-life recycling. So sometimes as we begin to look at these projects, we do need to think about those extra steps beyond the immediate project. And particularly as we look into Southeast Asia, into Asia, and these very challenging chemicals, materials that are involved in EV batteries, we have this opportunity to maintain them within the economy, to essentially downcycle them slightly into domestic or industrial storage as they reach the end of their electric vehicle life. But how do we recover those materials? How do we get them back from where we've sent them? One of the challenges we have in the Pacific Islands is the Basel Convention, where everybody is very happy to ship these batteries in vehicles as products out to islands, but then as it becomes waste, to try and recover those materials back to mainland areas, to areas where we can agglomerate these batteries, these end-of-life vehicles at a suitable density to facilitate economic recycling. We run into this challenge that it's waste and it can't be taken across borders. And even, as we look at the more exotic, the more challenging rare earth minerals, even on a national scale, are there sufficient vehicles, are there sufficient batteries to warrant a recycling system, to warrant a management system that reaches the economy of scale as necessary? So we've got to think about how do we get these batteries, how do we get these components back to a position where they can be remanufactured or recycled, and how do we overcome that challenge? So as we sort of go through today's discussions, we've got some fantastic experts here with us. I do encourage you to ask them lots of questions and to try and understand, but I would encourage you to think, as we are, about these larger systems, these larger opportunities for us as we design projects and as we invest in them, to not just focus on that transport section, but to look upstream, to look downstream. establish where those opportunities are for further investment and consider the whole circular ecosystem. So it's a challenging process, but it's also a very exciting process, and it's one that I work with on a daily basis. There is the challenge of focusing too hard on one aspect, but we can overcome these challenges. We do have some very good circular economy project templates now, some circular economy project case studies, not just focused around plastic, which is where a lot of people sort of bring circular economy from. And I do encourage you all to engage with us, engage with my team, and look at these opportunities. So, Johanna, I'll hand it back to you, and look forward to a good discussion.
Thank you so much, James, for putting this topic into also a wider context here and raising the opportunities for both economic development, but as well as some of the risks that we in the region will be facing, including for the Pacific Islands. So we'll definitely be creating or discussing how to create these enabling environments and also business opportunities in our panel today. But before moving on to introducing our panel, let me very briefly go through the house rules for today's panel discussion. So we strongly encourage you to post questions and comments in the chat to make it as engaging as possible. So, and also we aim to, at the end of the panel discussion, have some time for raising a couple of those post questions for our panelists' comments for the discussion. But please also engage with each other in the chat discussions, as that will definitely bring value added to the session. Otherwise, please keep your mics muted unless you're requested to speak. Of course, and for your information, this session will be recorded. So let's move forward to our panel discussion today. So as you know, we will be discussing the sustainable end-of-life management of EV batteries. There will be both discussion on the repurposing and reuse of batteries, as well as the so-called second life of batteries, as well as aspects relating to recycling of them. So first, we'll hear short presentations by each of the panelists, and then we will be moving ahead with the discussion itself. So after the presentations, there should be time for brief clarifying questions from the audience. So after each presentation, you can pose your questions if you have any kind of clarifications that you wish the presenters to make. Please add them into the chat and we'll raise them quickly after the presentations. We'll then, of course, have the chance to ask more questions during the actual panel discussion later on. But let me first introduce our panelists today. So and this is in the order of speaking. So first we have Mr. Georg Beeker. He's senior researcher at the International Council on Clean Transportation, where he leads the batteries and EV cost parity cluster. He holds a PhD degree in chemistry from the University of Münster in Germany. And he will be kind of framing the key issues relating to battery circularity and provide us with examples of best practices globally. Ms. Marie Carlson is the Vice President of Electromobility Solutions at Volvo Buses. However, very sadly, she has fallen ill today and had to cancel last minute, so she will not be joining us today. But I believe we should be able to share her slides with you later on when we're sharing the recording to all participants. We have Ms. Trupti Deshpande. She's Senior Program Manager for Electric Mobility at the Shakti Sustainable Energy Foundation. She has experience in the domain of public transport, electric mobility, and clean vehicle technologies, and she has an interest in policy analysis and has published articles on e-mobility and urban transport. And Trupti will present on the development of an enabling environment for recycling in India. And last but not least, we have Mr. Aylan Rao. He's CEO of Exico Recycling and has more than 30 years of management experience handling business units on lithium-ion battery management, as well as plastic and e-waste. He holds several advisory roles for industry associations and is core member of the Niti Aayog committee circular economy on lithium-ion batteries. He will be discussing the technical and business perspectives relating to battery recycling. And we have Jamie Letter, Transport Sector Group Director, who you already heard as part of the welcoming remark. He will function as our moderator for the panel discussion later on. But first, we'll go to the presentations by our panelists. So let me now hand over to Georg for our first presentation. Yes, thank you. Georg, over to you.
Yeah, thanks a lot, and good evening, good afternoon, and good morning, everyone. I will present a few slides, mainly coming from the study that we published last year around this time, with the title, the same title of the presentation, so Scaling Up Reuse and Recycling of Electric Vehicle Batteries, Assessing Challenges and Policy Approaches. So I will talk about both like the issues, but also the solutions that we see in policy approaches globally. So on the first slide, you can see a general overview of the benefits of recycling. So in general, recycling lowers the environmental impact and social impact compared to new raw material mining. So that's a first key point here, that whenever we talk about the environmental impact of recycling, we need to see that there are minerals that can be recovered, and using these minerals again compared to new raw material mining has an environmental benefit. Then there's less dependency in raw material imports. That's important for some countries' perspectives, and it can also create domestic value creation and jobs. On the right here of this slide, you can see an estimate on how much recycle can contribute to lower raw material demand. It has a lot of assumptions and therefore a lot of uncertainties, especially when looking in the further projection here. For instance, this assumes some shares, market shares of certain battery chemistries that are hard to predict for the future. But you can see still this as an illustrative example here on what recycling could do. So you can see the demand in lithium, cobalt, manganese, and nickel on this figure. The global demand for transport electrification. And you can see that if there would be an efficient reuse and recycling system globally with the same level of ambitions as European legislations, then there can be a large reduction in raw material, especially when going in the longer term. And that's an important aspect here, that recycling can reduce mineral demand only with the delay of a vehicle lifetime. So when a vehicle is produced, it needs to be driven for 15, 20 years. Maybe some of the batteries can be used in reuse applications for 10 more years. And then it really takes time from building the vehicle to having the materials again for recycling. And could you go one slide back, please? So could you show slide 9, please? Thank you. So there's a delay between vehicle production and the recycling, and this delay means that you can, it's only starting from the mid-2030s where you could really get significant amounts of recovered materials. But then when looking into the longer term, 2050 here, for instance, you can grasp all the benefits. And by then you could flatten the otherwise continually increasing demand in raw materials. On the next slide, there's a bit of an overview for reuse. If you, as I mentioned earlier, batteries can be reused, so they can be used in a second application after their application in electric vehicle batteries. And this reduces the demand in batteries elsewhere. So for other applications, you need to build less batteries, and therefore you reduce the raw material demand for these batteries for other applications, which could be, for instance, in households, but also on industry or grid applications to store energy from renewable power plants or from your solar panel you have on your house. And on the next slide, you can see like the process chain for reuse and recycling and all the challenges that occur across this chain. So at first, after the vehicle is not used anymore, you need the collection of the batteries. And there you need clear responsibilities, and also you need mechanisms to trace where the batteries are. Then in second step, for the transport, long distance transport can make the battery transport costly. So this is mainly an issue for the economics. And then you might have, or as of now, you can have very different licenses and safety standards for the transport of batteries, which also is an administrative burden that increases the cost and can be addressed by policies to standardize this better, so that if you have a safety license for the transport in one country, that you actually need the same conditions for continuing transporting that in the other country, so that you don't need 10 different licenses to transport a battery from A to B, but you only need one. So that's something for the transport. Then when the batteries enter at a center, they need to be inspected. It needs to be understood what's the remaining state of health of these batteries. And here it can really help to share the information that already is available. I will come back to this for the solutions part. Then the fourth step here is reuse. So if the battery is assessed as having a sufficient state of health, so if it's still good enough to be used in other applications, then this is a possibility. Here, challenge is that the management of operation in this new application can be very different from the one in the EV. So you might need to really understand the state of health of the battery and have a different software than you use in the EV application. And then the fifth step is disassembly. So the battery pack or module needs to be dismantled into cells depending on the recycling process. The other challenge is that you have very different designs of the battery packs, which can make this complex. And then the last step, recycling. Here really the challenges depend on the recycling pathway. So the classical recycling pathway is a pyrometallurgical recycling combined with hydrometallurgical recycling. So you kind of burn the battery and get a slag, which you can treat with strong acids to recover some of the minerals. Here you have the issue that you have air pollution or you can have, if you don't have a good treatment of that, you can have air pollution issues, but also you have a lot of wastewater that you need to treat from these processes, and you cannot recover all the minerals when you do this process. Then you can, as another option, go for hydrometallurgical recycling. This is a process where you don't burn the battery in the first step, but rather shredder it, and then you can treat the minerals more easily. You can get back more of the minerals that are used in the battery, but still does not allow the recovery as of today for graphite. And also you need to optimize this process for the battery chemistry that you are treating. But yeah, the benefits are certainly that it's you have a higher recovery rate and also less environmental impact because you don't have this burning process in the first step. And then the last option would be direct recycling, where you would directly recover the materials as they are used in the battery. So you would recover the cathode powder and use it again as cathode powder instead of first dissolving it in acids and going back to the raw materials. Both the way the process is described here, but also the three different pathways for recycling are schematic. There are lots of variations of this, and also for the recycling processes, there's a lot of in between. So that this is simplification here, but hopefully it's helpful for illustrating the ranges of possibilities. And then on the last two slides, I would like to present some best practice policy examples. But I will limit myself to only a few. So maybe the first one here, in order to have battery reuse, you need a battery that lasts long. And here, there's only very few regulations globally so far that mandate or regulate how long a battery would need to last. So far, it's mainly the warranties of the manufacturers that are available. But in California and also in the European Union, there are standards being developed, or in California, it's already adopted. And here in California, EV batteries would need to maintain still 80% of their certified test range after being run for 10 years or 240,000 kilometers, whatever comes first. And then maybe the last one is a good example also for battery information. So the battery, the battery regulation of the European Union foresees the creation of a battery passport, which is effectively a digital twin of that battery in a central system where the information is available on the state of health of that battery. And then when the battery is taken out of the vehicle, you already have the information of the state of the battery at this point. And if this information can be shared to reuse centers, that would be ideal, because they would not need to test them in a costly way, but could rather directly take the data that's already available. And then on the last slide, there are some best practice policy solutions rather focusing on the recycling side. And here I would like to emphasize something that is combined in the European Union's battery regulation, where you have both a mandate to recover a certain share of the minerals that are in the battery. So you need to recover 90% of the nickel that is in the battery, and also 90% of the cobalt, for instance, when recycling the batteries. So this really ensures that the battery, that the relevant minerals are taken out of battery, and not only those that are cheap or easy to get, but really those that are needed from the raw material demand perspective, but also from the environmental perspective. And then the second point here is that the European Union mandates that for the production of new batteries, there will be minimum shares of recycled content. And this is important. So when you produce a new battery, I don't have the numbers available, but let's say 5% of the nickel needed or used in that new battery needs to come from recycling of old batteries. So this is a way to ensure that you don't have downcycling. So when you recycle a battery and recover the minerals, you might not recover them in a quality that is good enough to use them again in the same applications. And this is the point here. So when you mandate that the minerals need to be used in the same application again, you can ensure that the quality is high enough. So I will stop here since I ran over time already a lot. Thanks a lot.
No worries. Thank you so much, Georg, for these really interesting insights. And also kind of providing us with some key challenges that need to be addressed, as well as some pointers already on how those challenges can be and have been overcome in different parts of the world. So do we have any clarifying questions for Georg at this stage? I can't see anything in the chat, so I believe we can move on to Trupti now. So let's move forward to Trupti to hear a bit more on how some of these topics have been tackled in India from a policy perspective. So over to you, Trupti.
Yeah, hope you can hear me clearly and everyone can see me as well. Good morning, good evening, good afternoon, everyone, wherever you are. And without wasting a minute, I'll directly jump onto my topic because of limited time. I don't want to skip on any point that I have listed for today. I'll today discuss basically on the Indian scenario. I'll run through the need for battery recycling, key points that are covered in the battery waste management rules in India, and what are the key challenges and way forward. Can you move to the next slide, please? Yeah, so we have seen that in India now the EV acceleration is very high. Since 2021, we are experiencing exponential growth in electric vehicles. Post-COVID, plus the FAME scheme getting through, and the steep exponential increase that you see in two-wheelers is because of the price parity that we have achieved. Multiple manufacturers have come into the picture. And that's why this increase. This is a clear indication that we really need to think about battery recycling, because we'll have number of batteries in the coming few years, 5 to 7 years or 10 years down the line. We'll have these number of batteries to be recycled. An estimate shows that by 2030, we will need 15 gigawatt hours of battery only for commercial purpose. The total need goes to around 600 gigawatt hours. And this 15 gigawatt hours itself is almost 15 times the current 2022-23 requirement. Can you please go to the next slide? So the battery waste management rules in India as of now, they cover all the batteries, including electric vehicle batteries. They also have extended producer responsibility covered. They have an online portal wherein you can have the producer can exchange certificates within themselves. This also helps the battery manufacturers, battery recyclers to get into touch with the battery producers, and they can exchange credits and exchange certificates. And this enables the small recyclers also to get in touch with the bigger recyclers. So this is a win-win situation for everyone. It also includes principle of polluter. It has a component: if the producer doesn't comply with the EPR, then there is a penalty that the producer has to pay. This same penalty is then used for the batteries that were not collected to recycle those batteries. There is a clear target for battery recycling, which says 70% by 2024-25, 80% of the material to be recycled by 26, and 90% 27 onwards. Can you go to the next slide, please? Yeah. So talking about the key stakeholders, these are the few ministries that play an important role for battery recycling in India. Though Ministry of Environment, Forest and Climate Change, which is MOFCC, is responsible to come up with the battery waste management rules, Ministry of Mines, Ministry of New and Renewable Energy, industry associations, and state government, as well as central and state pollution control boards, play a vital role. Can you please go to the next slide? These are the different roles that each of the ministry has to play. MOFCC is responsible for formulating guidelines and coming up with the battery waste management rules. Ministry of Mines is responsible for management of the critical raw materials in the nation. Industry associations play a vital role because they act as a bridge between government bodies and industry players. They have the knowledge of technical challenges, technical requirements of the manufacturers, and they can communicate those challenges to the government to come up with the policies that can cater to the requirement. MNRE works towards formulating rules for handling batteries when they are in the operational phase. The state and central pollution control board builds consensus towards battery collection. They also manage the portal that is there, the online portal for manufacturers, which is there for the government portal. Can you please go to the next slide? Though we have quite stringent battery manufacturing rules coming up and the amendments are going on, there are a few gaps that we are working on currently. One is lack of labeling information. So if the batteries currently, all the batteries do not have the mention of the chemical composition, which is very critical for any recycler to take up the recycling process and understand how to recycle that particular battery. So that is one lacuna, and probably we'll come up with an amendment soon. EPR implementation mechanism. So EPR is there in place, but the tracking mechanism is still lagging. How many producers are actually adhering to this particular mechanism is currently not being tracked to the 100%, and that mechanism is also being developed. Budgeting for waste material and recycling. So there has to be a set standard which gives a guideline to the manufacturer as well as to the recycler, how much amount to be allocated for the battery collection, for battery recycling, how does it work, what are the economies behind battery waste material collection as well as recycling. As Gorg already mentioned, a lot of it is being spent on the travel, the transportation of the batteries from the origin or their disposal to the recycling plant. We are like paying a high cost for that particular transportation that can be curtailed if we have a kind of budget and guidelines where to recycle which particular battery. That framework has to be there. Informal sector competition. So there is no set rate for recycling batteries or recycled material. This plays a key role to keep the informal sector in track, because though informal sector as of now, especially in India, be it vehicle scrapping, be it two-wheeler manufacturing, be it battery manufacturing, a lot of informal sector has been flourishing, and though they are the key part of the whole ecosystem, we need to formalize them to have a safety standard in place. So the next point that comes is safety standards and handling of batteries. So all these operations need to be aligned to each other, and they need to come under one umbrella, one particular purview, so that everything comes in track, everything is labeled, everything, there is a tracking mechanism in place, and we adhere to the safety mechanism as well. And we have a guidelines for handling the batteries, transportation of batteries, and recycling of the batteries. Can you go to the next slide, please? Way forward. So the way forward basically comes from the gaps that we have seen. We need to standardize the battery collection mechanism, the disposal mechanism, the labeling mechanism. We need to standardize the black mass composition. The black mass composition depends from each manufacturer to manufacturer as well, irrespective of the battery chemistry. It also depends, varies from the manufacturer to manufacturer. We need to have some sort of standards for black mass composition, so that we have a recycling process also adhering to the same. Developing a framework for traceability. How many batteries are being produced by the informal sector as well? How can we formalize that? How can we have a track of the total batteries that are to be recycled in coming 5 years, coming 10 years? That traceability of a number of batteries, and that also has to be there. Budget allocation guidelines. We need to understand how much is required for recycling of batteries, how much should a producer keep for recycling. This will also enable the informal sector to adopt to the formal sector, and it may remove their barriers from becoming a formal recycler. Environmental auditing standards. So we can also develop environmental auditing standards, which again will formalize the whole sector. And as of now in India, R&D is kind of lagging when it comes to battery manufacturing and battery chemistry. Though we are giving it a push, only 20 to 25% of the total investment is going into R&D. So that investment needs to really increase to see new battery chemistries coming up, which are easy to recycle, which have more recyclable material included in that. And especially the raw material should be domestically available to avoid dependency or reduce dependency on foreign exchange. Yeah, so I'll end my presentation here. Thank you.
Excellent. Thank you so much. Thank you so much, Trupti, for providing us insight on the policy perspective for India. And just to mention that this focus on India, we think will also be interesting for especially lower and middle income countries in the region to better understand the challenges and potential solutions as well here, not only to look at, for example, European examples. So, but do we have any clarifying questions for Trupti? I think this one from Moshi is not directly to Trupti. So let's move forward now to keep our time. I'll hand over to ALN Rao to provide us with a perspective from the recycling industry in India as well. So thank you. Thank you, Trupti, and over to you, ALN. Thank you.
Thank you, Jona. Good afternoon, good morning, good evening, ladies and gentlemen. Pleasure being here, speaking to you on recycling. And in a few slides, I will be talking about policy in continuation with what Trupti spoke, and also about recycling, a little bit about what Gaurav did mention also, and the challenges there. So can we go to the next slide, please? Right. This is a scenario where we're looking at Ideally, to start with, we had the consumer electronics earlier, where the battery supplies used to happen. But in the last 3-4 years' time, the EV industry boom started, a lot of support by the government of India. And we're looking at different scenarios here where for two-wheelers to three-wheelers to cars and commercials, the numbers that speak about is at an annual level, we're looking at around 14 million units, and that's to be sold. Whereas by 2030, we're looking at around 61 billion units there. However, if you see, this is all the low adoption rates that we have given. But if you were to look into your high adoption rates, we are looking at 100 million units that will be in operation in the country. And two-wheelers, obviously, India, two-wheelers and three-wheelers will contribute a lot to the country. And so the two-wheeler batteries and three-wheeler batteries from around 15 kgs to around 30, 50 kgs are the ones that will be maximum that will be there disposed of in the country. Next slide, please. Right. Now, because of this, what's the demand for batteries that we're looking at? Now, as Tutti also said, we're looking at around 600 gigawatt hour by 2030 in the country. Now, the breakup is what here it is, where consumer electronics and the grid applications and behind the meter, but EV, it contributes the maximum. It goes up to 380, 400 gigawatt hour. Now, with these volumes, we are looking at something around 120, 130, 150 gigawatt hour of batteries will be available by 2030. Currently, we are there at around 6, 8, 10 gigawatt hour of batteries that's already there in the market. And two-wheelers, three-wheelers are the maximum that comes in. And R&D batteries are coming in for recycling now. So the EV segment alone will be somewhere around 60, 70, 80 gigawatt hour of batteries that we will be receiving for recycling. So that's substantial. There are recyclers available in the country. There are 3 or 4 recyclers only who are into the mechanical and the hydro or the pyro or the direct recycling processes. But mostly there are 20, 30 recyclers who are there up to the black mass level or the mechanical recycling level, I would say. Go to the next slide, please. Right, so having spoken about the batteries that's coming in, there are 2 sides here which I worked out. One is the material recovery. If you see, lithium is 17%. The overall, we're looking at around 300,000 tons of material that's there available for recovery from the numbers that I spoke about for batteries available for recycling. And the maximum would be graphite at 26%, but however, cobalt would be at 17%, lithium at around 17% again, nickel at 4%, at 2% would be manganese. Now, I've also put in here where the type of metals that can be recovered by hydrometallurgy and a few that can be recovered by pyrometallurgy. But lithium, 100% is from hydrometallurgy only for matter. Transferring that onto the revenue stream there, we're looking at around 7 to 8 billion USD of the size of the market of this recovered materials there, whereby lithium is contributing on 45%, substantial, then followed by cobalt, which is 33%. Cathode material, more global supply chain issues there. So countries trying to safeguard these commodities within the country. And this is an area where I think India is focusing very, very big way to ensure that all these commodities here are retained within the country and used for new products manufacturing. Next slide, please. Right, so continuing from what Tripti said, BWMR, Battery Waste Management Rules 2022 got introduced. I've been part of the policy making for 3 years, writing the rules literally. And the key players are the producers and the recyclers and the refurbishers. These are the 3 main players. Of course, anything and everything now is digitized, and there are APR certificates that will be transacted on a portal. And there are penalties also that's been announced for recyclers and for refurbishers and producers. The challenge that we had was because there are different types and shapes, size, form, volume, weight, composition of batteries. So while policy making, we had this challenge to bring everything together. Finally, we were able to put that together now. So the categories that we have designed is portable battery, chargeable and not rechargeable, then automotive batteries, industrial batteries, and electric vehicle batteries for two-wheeler, three-wheeler, four-wheeler and above. So this is the 7 categories that's been defined in the rules. So there's clear-cut definitions that's been set in for the industries that have come up in this particular sectors, I would say. Next slide, please. So it's a carrot and stick approach that's there, which the government of India has taken. And to ensure that the local manufacturing increases substantially, the objective is that how does the commodities that comes out of a recycling facility, reaches the producer back. So the targets that's been given from 24-25 for a recycler are the recovery targets. So it differs product-wise, and it starts from around 55%, but it reaches all the way up to 90%, which means that 10% could be the maximum, that is the hazardous waste that's there, but remaining, the recyclers are expected to put in technologies and processes through which they will be able to recover anything and everything. Efficiency rates about 90-95%. Minimum 95% efficiency rates are the need of the hour for Indian recyclers, else we will not be able to survive there. But as a producer, the idea is that from 5% to 40% is the targets that's been given for producers for the material to be used in new product manufacturing. They have said materials and they've not commodities to start with, because the ecosystem, once we develop, then we would be going into materials and then cathode materials and anode materials. That's the next level that we will get into going forward in the country. Next slide, please. All of you know about the circular economy, the loop that's there, but the most important thing would be the second life and recycling. So can we go to the next slide, please? Right. So when I say second life, the objective here is that the SOH of the battery is the most important aspect. How do you diagnose the SOH within the plant, within the dealer outlet, or remotely? Now that's a challenge which we have started working and many places in the country too. What are the 5 elements that are there after a battery is to be discarded? Reconditioning, refurbishing, repurposing, reusing, and recycling. These are the 5 levers that are there. Anything about less than 60% SOH goes in for recycling, but the rest 4 are the ones where you can identify either the pack or the module or the cells, replace accordingly, put it into different applications and reuse them. It could be reused from a high-speed vehicle to a low-speed vehicle, or a grid scale, or renewable energy, or backup powers, anywhere for that matter. So the challenge is understanding SOH remotely, working out diagnostic tools, AI-based pricing engines, transfer of ownerships of the batteries, and then further taking it to the next level and ensuring that any of the steps here is followed there. Next slide, please. Gaurav did mention about the processes. This just to give you a small idea about what happens in the mechanical of dismantling, discharging, disassembly, and shredding, where sleeving, screening, and filtering takes place in the mechanical treatment. And black mass is recovered, where the aluminum, plastics, and copper is removed separately. And there are some recyclers like us. During the mechanical, we're able to recover the electrolyte solution also that comes in. But however, in the hydrometallurgy, that's the most preferred one, where it goes in and people are able to recover salts, hydroxides, your oxides, carbonates, sulfates, and so on and so forth. And then MHP, which is metal hydroxide powders that can be used to make virgin metals much faster, and then goes in where leach liquor that can be used in calendaring processes of the cell manufacturer. These are the different levels where recyclers are looking at in a big way. Next slide, please. So one of the most, this is my last slide, the demand uncertainty is the most important one. We see the EV phobia that existed earlier, is it actually happening worldwide and in India? I would say no, it's a bit subdued. Similarly, the battery pricing, we're looking at what the battery pricing currently stands in between 135, 140 USD per kilowatt hour, expected to reach the level of around $60, $70 USD in the next few years' time. Then second life, will it become applicable or not? Will there be application-specific batteries that will be manufactured by producers? And so many questions out there for recycling perspective and refurbishing perspective, but that's the demand uncertainty that's there. We also know that cell manufacturers are developing various evolution of technologies are taking place. So as a recycler and a refurbisher, the challenges for us are, the type of glue that's being used and how do you actually discharge, dismantle, and then put it into a new application, make it a new product and sell. And then secondly, the chemistry, the quality of cells that comes in. We are able to see different qualities from different countries, A grade, B grade, C grade, D grade, and so forth. Battery traceability, I think many speakers did speak about, so let me skip that. Governance mechanism, I being in the steering committee also as implementation member in the Central Pollution Control Board and representing the recycling community in the country, we see this as a big challenge. But the idea is that batteries are new, so we are able to put in policies and guidelines in a better way. Tracking and tracing is easier, but it's going to be a bit uphill task for us going forward. Next 2 years' time, I think we'll be able to settle. And last but not the least, collection, handling, packaging, shipping, transportation, warehousing, all these are elements which are going to be challenged here. So this is something which India is working on. So let me end here and thank you very much, Lucy. Sure.
Thank you so much, Ayal, and for these really insightful technical perspectives, both on actually battery recycling and second life. So, and also for sharing on the challenges from a recycler's perspective, which was really interesting to hear. I don't see any clarifying questions in the chat, apart from, I don't know if you are able to respond to Angel's question on which is the investment in equipment required for a mid-sized battery recycling plant. Not sure if this is information that you have available, but you can also respond in the chat if you don't have that kind of directly.
It can, in the sense that I can talk in rupees to start with, or we can say to put up a mechanical process anywhere from around 300,000 to $1 million USD is what we will be able to put in a mechanical recycling unit, but it's 1,000 tons per annum capacity I'm talking. And if you had to put in a hydrometallurgical unit, we would need something around $1 million to $3 million. Yeah, around $5 million is what we would require for a hydrometallurgical unit. Yep.
Okay, perfect. Thank you so much. And let's move forward very briefly to this engaging session that Tom Fleming from our implementing partner Integrated Transport Planning together with Divyesh Lama will be running. So let's move forward to this kind of engagement with participants, and then very briefly we'll be back with the panel for the panel discussion. And thank you. We see there's a lot of discussion already in the chat, which is great. Thank you.
Thank you, Johanna. Hello, everyone. It's a pleasure to follow on from such excellent presentations. And as Johanna said, before we dive into the panel discussion, we wanted to pause for a few minutes for some reflection and discussion. As you can see on the slide, we have called this section community engagement. In this section, we will have a Menti poll followed by a couple of topics for discussion on matters of interest to the platform. So the aim really being to take a bit of a temperature check within the room and understand what we know when it comes to battery end of life, waste management, and what's being done on the ground. I understand that there should be a Menti link to the Menti poll being posted in the chat. You can also see question here. Yeah, so to begin with the Menti, the question is, how prominent is the issue of battery waste in EV policy making in the country or region that you work in? So we have responses on a scale of very prominent, quite prominent, not so prominent, and not at all prominent. Divyesh, could I invite you to explain how this is going to work? Divyesh, are you there? No, okay. So you should be able to access the poll by the QR code on the screen. As you can see, if you have a smartphone at hand or similar device, you can scan that and you should get access. There should also be a link being posted in the chat. Yep, I see Johanna's put it in the chat there. So hopefully we'll start to see some responses coming through. I think we might need to refresh it. There we go. Super. Okay. So that's good. This is positive to see. So yeah, 6 responses so far, half of which are for very prominent. So that's positive. That shows that this is a live issue, topic of interest for us in the region. Also one response not so prominent, highlighting that more needs to be done. I think we're probably expecting to see a bit of a range here, recognizing that the different countries are at different levels of development, with different levels of industrial capacity as well to handle, to respond to the challenge. So I don't know if that's if we refresh it again, if we see a few more responses. I'm conscious. Want to encourage as many of you as possible who feel you can you could usefully respond to this to do so. But this this will remain live as well throughout the session today. So if you want to dip back into the link in the chat, you can access it there. Divyesh, is there any more, or should we move on? I can't hear you. No. Okay. Well, let's skip on. Let's move on to the next slide. Super. Okay. So points for discussion. So as described, we want to create some space for discussion with all of you on the call, building really on what we've heard so far on our excellent presentations. We have prepared 2 questions, which you can see on screen for this discussion. These are: what do you consider to be the most feasible solutions for managing battery end of life in the countries you work in? And tell us about any initiatives happening in your countries today. So it's reflection on what we think are viable solutions and what we know is being delivered today. So for this section, the house rules will be slightly different to the ones that Johanna highlighted at the top of the call. We want to promote some engagement here if at all possible. So please do raise your hand if you'd like to speak, and we'll bring you in. Equally, feel free to share your thoughts in the chat. Conscious that it's great to see the level of activity in the chat so far. Lots of engagement, lots of exchange taking place in there. Using it for what it's designed for. So that's excellent. So I don't know if I'll just pause here and invite any contributions. Anyone who'd like to raise their hand to make a comment, you can do so using the reactions button at the bottom of your screens. So just pause here and see if we have anyone brave enough to share. And equally, I must say, if anyone has any reflections on the presentations they've seen or any of the discussion that's been taking place in the chat, please feel free to come in at this point with any insights there as well. Okay, I see Samir has posted, would love to know about EV ride sharing services in India, if anyone can share. So yeah, it's another. ALN, you have raised your hand. Would you like to come in?
Yeah, I'd like to explain about this particular point that's there on the screen, the most feasible solution for managing battery end of life in the countries. Yeah. Just give me a second.
Yes, please.
Am I audible?
Yeah, then you're very quiet there. I don't know if your mic has moved away from your mouth at all.
Yeah. Am I audible now?
You are, yes, that's much better.
Okay. So the idea here is, how do we actually, work from a buy-sell methodology to a collaborative model. And that's what we see a change happening in the country with automotive people, the producers trying to work with recyclers right from the R&D stage itself, understanding the BOM of the battery and the composition and trying to find out solutions for the various commodities or metals or materials that's available in each battery. Now, in that way, what happens is the costs are kept to a minimum in this way. B, the batteries are very expensive to ship and it's not safe too. So the hub and spoke model is the one that is being looked into. We at Exigo, we are already active on that, where I am able to put in a plant-in-plant concept that fits into 2 40-feet shipping containers, either in any of the geographies that is there or inside the automotive plant itself. So in that way, the batteries are and in that particular city or town. So what happens is the local, hyperlocal model where batteries are collected and it's been converted into black mass. So safety as well as shipping becomes much, much better. And 3, as Trupti mentioned that the informal sector is a major concern. So how do we set the tone for recyclers and producers to work a range as far as pricing is concerned? And that's an exercise which we have started as a country. And if this happens, I believe there will be clarity also as far as pricing is concerned. Again, it's linked to the global pricing, commodity pricing. And we know the pricing for black mass at how it happens, like 60 to 70% based on cobalt and the lithium contents available or nickel contents available in the black mass. So something like that, which we are bringing in. Last but not the least, sampling of the battery, the black mass or the commodities is the key, which is being looked into seriously. We have AHKs and the SGS globally, but here India is developing something on our own, and we believe that will really work. So these are the 3-4 feasible solutions that we're looking at here in India.
Super, thanks so much for that, Alan. That's really good insight, and yeah, just excellent to know what's in development and what's kind of coming down the line in such a dynamic space. I think just conscious of where we're at with time. I think at this point I will hand back to Jamie Leather, who is going to lead us through the next section, which is the panel discussion. Jamie, over to you.
Thank you very much, Tom. And I think you'll all agree there was a wealth of knowledge, complex area, but the insights provided by all of the speakers was quite incredible. And I like the fact that a lot of the opportunities were really stressed. We did say there's a lot of challenges, but I think there's also huge amounts of opportunities here. If I could go to the panel members and just ask a few questions. I'll go through in the order. So starting with you, Georg. you gave a couple of slides looking into the details on recycling and reuse. I know this is a very complex topic, but let me give you a very simple question. I hope the answer is equally simple. But in your mind, what is better, recycle or reuse?
Yeah, that's actually quite simple to answer as well. Both. So you first need reuse and then recycling. So you can you can still recycle it, right? But after you recycle, you can't reuse anymore. So with every recycling step, there's only so and so much of the minerals that you can recover. You can never recover 100%. So it's best to use the minerals while it's in the batteries as long as possible. That increases the efficiency of mineral usage.
Thank you very much. Is Trupti still with us on the call? Because I have a question.
Yes, I'm here. I'm here.
Okay, great. Excellent examples in a couple of couple of the panelists on India, and indeed they're making huge moves in the right direction, and then that the way the government as a whole is supporting that. But given the experience and the process that the Indian example has gone through, what do you think are the key policies or regulations that could be used in other low to middle income countries? I know the institutional structure you referred to is quite complex or quite India specific, but what would you see as the key criteria that we should share and other countries should be considering?
So one major thing is, as you rightly mentioned about the complexity of the different ministries that play different role in India. An institutional mechanism is a vital thing in battery waste management, because different ministries have to come together to success the battery waste management rules or the battery waste management ecosystem. That is one. Second thing is tracking and tracing of batteries, mentioning of the chemical composition of each battery, and probably the mechanism to recycle the battery, which is a very small component, but mentioning of the same on the batteries is something each country, irrespective of the economy, can do it. And this can really help the recyclers to recycle the batteries faster and can segregate the batteries as well. Another thing is guiding the economies, allocating proper budget for R&D as well as for recycling of batteries, how to recycle batteries, what raw materials need to be used, what raw materials, how should the economies work on recycling of the batteries, how to allocate the budget for recycling, which material should be used. That is really important, and definitely all the economists should definitely spend more or invest more on research and development to come up with different battery chemistries.
Thank you very much, Trupti. It looks like you're multitasking. I think your son is joining in the conversation as well. Let's not forget the brighter future, particularly for all of our children. So that's great to see as well. Mr. Rao, if I could turn to you, and I think maybe part of that last question as well, with Niti Aayog, that government's approach, perhaps you could also look at the government's concerted effort across many institutions. That's one part of the question, but the other one is really looking at the private sector side. What factors or the enabling factors would allow the private sector to come in? And you mentioned, I think you were responding to some of the questions in the chat as well. What the 300,000 to $1 million, but what is that enabling environment, and how can the policies and the government side set those enabling environments to ensure that the private sector is welcomed or encouraged to join in?
Good question, Jimmy. So to the first question, there are 11 waste management rules that the government of India is announcing. E-waste, batteries, plastics, tires, oils, ferrous, non-ferrous, end-of-life vehicle, another 3. Now, the challenge is, how do you bring in all this together onto a platform? Now, that's a mammoth task, right, for a country like India. So as of now, individual rules, individual portals are being given for the stakeholders that are there, right? Now, example, in batteries, you have plastics, you have aluminum, copper,
and you have your cathode material also, for that matter. So the challenge here is it's not just the lithium, nickel, manganese, and cobalt that's important. It's also the copper, aluminum, and plastics. So how do you bring in the levels of recyclers? So we have 4 levels. The R1 is a lead acid recycler and smelters that's there. And B, for the other lithium-ion batteries, R2 is a recycler who is only up to the mechanical level, up to black mass level. R3 is only a refiner who takes the black mass and refines and takes out the cathode material out from there. And R4 is a mix of recycler and a refiner. So that's the way definition in batteries has come in. 2, combining both your questions, technology is a very, very important aspect. Many recyclers here, they're all families who have invested their personal wealth more out of passion and have come out in this business. Because there's no technology, even if fund capital is available, how will somebody want to get into this business? So the government worked out with the BARCs and the CMETs and the CIPETs and NMLs, the Central Scientific Industrial Research bodies, these are, to work on technologies and which are cost effective and license these technologies to startups who want to get into this industry. That's something which has been achieved, and there are cost-effective technologies available there in battery recycling. B, capital, under the Department of Science and Technology, there are bodies there. The Technology Development Board is offering capital to the startups at very simple interest of 4%, 5%. Capital is a very, very important aspect here. But however, these are all small scale levels only. But somebody like Exigo V putting up a 20, 30, 50,000 tons battery recycling capacities needs millions of dollars, I would say. And that's not there yet. And so it's in the POC level now. The investors are looking at the Indian market seriously. And I believe there will be various recyclers. Of late, recently, a recycler raised $50 million from investors. But I believe that going forward, there will be a rush, there will be a crowd in the country. So as private players, we have ensured that the batteries that are coming in are not going to the landfill. We have designed, developed technologies on our own, cost-effective, high yield at low cost. And machineries is a very important part because of heterogeneous material. So we worked on our own in designing, developing machineries that has to change over time and offer solutions to the complex materials that are coming in and will be coming in. So these are the few steps which we have taken in the private sector. Yeah.
Thank you, Mr. Rao. You've given quite a few examples, but let me ask Georg and Trupti as well, whether and this is a question from the audience, other examples of mass use or reuse of batteries. Are you aware, and can you share that? Any examples that you're aware of? Either Georg or Trupti? Georg.
Maybe I go first. The point here is that there are not that many batteries already at this stage being available, right? Because they have just been built in the vehicles, and it takes time for them to reach the end of life in that application. So we will see this only in maybe 10, 15 years from now on a mass scale, scaling up. So far, there are like some pilot projects. So in Europe, there are some OEMs, Renault, for instance, they do some projects just to try it out, how a used vehicle battery can be used in other applications. So there are some pilot tests, but I would not speak of any mass take up, and I would expect that only in maybe a decade from now to really pick up.
Shall I add in this, Jeremy?
We're sort of running short of time. There's a number of other questions, so let me jump to one of those. From the mass example, let me go to the other extreme. And clearly, Asian Development Bank covers Asia and the Pacific. Now, India, some huge numbers were being put up on the screen in those presentations. At the other extreme, some of the small island countries, as an example, how would an end-of-life management system be applicable when you're talking significantly smaller numbers, particularly in Pacific Islands or even some of the less densely populated countries in Central Asia or parts of Southeast Asia? If this impacted scale, great. But how, and I may come to one of the questions that was raised, is there an opportunity for regional action beyond one simple country and sharing those as well? But any thoughts on the smaller markets and how to engage with those and ensure that the sustainability is embedded within those smaller markets for e-vehicle and end of use or reuse? Thank you. This is to anybody. Georg, please go ahead.
Yeah, thank you. Just one thought, please. I'm not an expert on small markets here, but my 2 cents to this would be that it's key to have harmonized transport policies across countries, so that makes it easier, in the end cheaper, to transport batteries from A to B. I think that would be a key thing. So yeah, to just drive down costs and administrative burdens to ship the used batteries.
Sorry, I was just trying to read up on the informal sector. I think Trupti has already answered or responded to the more on the informal sector as well. One more question on the major business opportunities. Again, we were saying there's some challenges, but also we should see those as opportunities. But what are the major business opportunities in the market at the moment, as you see that? Where is the opening, and where could potential investors or financial institutions like ADB provide or should be targeting at this stage? I know you said, Georg, that the batteries are sort of going through their use within the vehicle, but at a certain point we need to plan ahead, particularly if we need to set up the infrastructure to be able to reuse or recycle those batteries. So any suggestions or thoughts on how we can be ahead of the curve to make sure that it's addressed before it becomes an issue?
You're addressing me? You're asking me?
Let's go ahead, Mr. Rahab.
All right. Electricity is a key component here. And if we were to put in second life batteries, it usually works with fleet operators and with swapping of batteries. That's the industry India is moving in a very, very big way, and a lot of investments happening there. Type of vehicles, again, high speed, low speed vehicles, we can put in these batteries, it can be used there for second life. Third, solar applications, storage applications. This is where mostly it is being used. Solar, we know we are there at around 60 gigawatt hour. We're looking at around 1,500 gigawatt hour of solar penetration in the country in the next few years' time, where again, batteries are going to play a very, very important role. And that's where the batteries, the new batteries, as well as the second life batteries are going to be used in a very, very big way there, under renewable energy there. And so the idea is, on the one side, what is the potential available for usage of these second life batteries, right? We have seen at a mass usage, we have not seen there, but we are seeing solutions that are being available where we are trying to work and implement the same at a mass scale. But however, again, I come back to the same question. If the cost of a new battery drops from $130 per kilowatt hour to 60-70 USD per kilowatt hour, the industry of second life, will it be there, not be there, is the question. And if producers are able to design, develop batteries that fits multiple applications, which are very, very low cost, then the second life will not be there. So is it wise to invest in the second life industry? Big question marks currently, right? Since it's nascent for everybody for that matter. And last but not the least, preference is always there to extend the life of batteries. But not every battery can be done. Not every chemistry can be done. LFP, LTO, NMC, LCO, multiple batteries, new batteries that are coming in, solid state batteries. So not all chemistries that can fit into the second life. Only a few chemistries can fit in. Only a few shapes and size can fit into this particular second life industry. Yeah. Thanks.
Thank you very much. Let me ask each of the panelists to share a very short, their views. What is the single most important aspect that looking at the circular economy of batteries? And given the e-mobility, this is the elevator pitch, another form of e-mobility of electric elevators. But what would be your 30-second single most important circular economy for EV batteries? And maybe we'll go with Georg Trupti and then you, Mr. Rao, on that single most important thing.
Yeah, I would maybe it's two things combined. So you need to plan. You need to plan ahead, and you need to plan on a comprehensive level. So I made the point that the volumes for batteries to be there for reuse and also for recycling are not there yet, and it will take time until they are there. But still, it's important to act now for policymakers and for the private sector to develop the capacities to be able to meet that wave when it's coming. So therefore, that requires planning, and it needs to also like a economy-wide planning. It doesn't suffice. It's not sufficient to only think about the transport sector and what about doing batteries there. You need to think like in the broader scale. Where are other applications for the reuse of the batteries and also for recycling? That's you don't need to think in only the transport sector silo, but economy-wide.
To you on your elevator pitch for circular economy of EV batteries.
We need to set targets first, carve a pathway, understand the challenges, and then allocate the required resources, investment, come up with institutional mechanism, and have a mandate for adhering to all these to get a circular economy in place and build the ecosystem for the battery waste management.
Yeah. If the producer, whoever is the producer, he looks at the battery as the commodities inside and not the battery pack. If the producer thinks that he is the owner of the commodity, and if he tries owning it for life, it's a mine, literally, urban mine, right? Then the producers would start working with cell manufacturers and recyclers in a collaborative model to keep the cost low and finding technical solutions right from design stage all the way up to second life and recycling and reuse commodities again and again for making new battery packs for their use or for their customers. That model is the one I believe going forward, most of the stakeholders will be looking at. And that model in its true circular economy, right? A businessman thinks like a businessman.
We may have lost you, Mr. Rao. Oh, you're back. Sorry, you're cutting in and out. Let me thank the panelists for the presentation. Clearly a hugely complicated area, a complex area, but significant opportunities. And perhaps above all, bidding this is a platform for sharing information and sharing knowledge. There are a lot of great examples that are already underway. And I thought that last point on looking at this whole life cycle cost and putting that planning process right at the start will allow for a much better and more sustainable future throughout. So thank you all very much to the panelists, and I'll pass it back to you now, Johanna.
Thank you so much, and a very big thank you to our panelists, as Jamie said, also to Jamie for moderating this really insightful discussion. Highly appreciated that you joined us today. Also, a big thank you for our participants for listening in. So yeah, I guess also to sum up a little bit, I think we've heard many pointers on where issues can be found in this sector. It seems like a lot still needs to be done, and that we have also seen a lot of policies in place around the world, including in India, China, EU, and the US, where we can get some lessons learned from these cases. And there are some Asian Pacific and lower and middle income country specific issues also relating to exportation regulations, informal recycling sector, etc., that also need to be targeted in particular in this region. So, and finally, I guess we've heard that planning now is definitely needed, or taking action now to be ready to meeting the challenge when we actually are met with these large amounts of used batteries in the coming decade or so, and engaging with a various group of stakeholders to actually successfully conduct these plans. I guess just to close off, if I can get the next slide, please, Divyesh. We wanted to mention that we have some upcoming webinars, and especially our next week's webinar is highly relevant to our topic today, so it might be of interest. We will have Mr. Yu-Tak Kim present on the second life of batteries. That will be next week's Wednesday on the 10th of April, 3 p.m. Manila time, so the same time we started this call. And yes, the link is in the chat now. We also have our colleague Jiwoon Kang from ADB to discuss the second-hand market of EVs on the 24th of April. So we hope you can join those. We will be sharing the recording of today once it is available with all registered participants. And thank you again for joining us. We look forward to seeing you in our webinars and future panel discussions as well in the future. Oh, and actually, sorry, I forgot. If you can go back to the past slide. So we also do have this e-mobility platform survey. So if you want to join our mailing list, please fill in the survey. There's a possibility to tick a box for being included in the mailing list here, so you will be stay up to date on any of our activities with the platform. So thank you again. Wishing you a very excellent rest of the day and week, and hope to see you soon again. Thank you.